So the second part of the surds one is multiplying out the brackets. Just we did multiplying out brackets earlier, and now we've got to do it with these surds. So this first part here, I've just got 3 times by the square root of 2. Now I'm going to times this root 2 by this root 5, and root 2 times root 5, well, 5 times 2 is 10, so I've got root 10 here. Let's work on this one here then. I'm going to multiply these two bits together, which give me the square root of 12. And then I'm multiplying these two bits together, which is going to give me the square root of 48. Now I could leave it like that, or I could actually try and tidy that up a bit. That earlier we worked on simplifying these ones. And the square root of 12, well, that's 2 root 3's. And the square root of 48, we did that one, didn't we? Look, the square root of 48, that's 4 root 3's. So in total, you could tidy that all the way down to be 6 root 3's. Here, then I've got 4 root 5's, and just 4 times 3 makes 12. Okay. It's not complicated. Now we've got a few more bits to work on here. There's going to be 4 bits to this answer. I've got 2 from the first bit. Now, square root of 3 times the square root of 3 is the square root of 9, because the square root of 9 is just 3. There, I've got a root 3, and there, I've got another 2 root 3's. So lots of tidying up. Here I've got 5, and here I've got a grand total of 2, and another one, 3 root 3's. That's my answer there. Same idea here, let's multiply this out. So I've got 3 times 3 is 9 here. It's an interesting one. So I've got 2 times by root 5 times by another root 5. Well, when you times the root 5's together, you get 5. 5 times 2 makes 10. I've got minus 10 there. Now the middle bits, so I've got 3 root 5's from the middle there, and 3 times 2 makes 6 root 5's from the other bit. Altogether, minus 1 from there, and minus 9 root 5's from here. Careful with your negatives. Multiplying this one out, well, they're different numbers here, so there's not going to be as much tidying up here. But I've got 2 times 2 makes 4. Root 5 times root 3 is root 15. There aren't any square numbers that go into 15. And then I've got 2 root 5's from the middle and 2 root 3's from the end. And that can't be tidied up. There's nothing else I can do with that. That's the lot. Same issue here. We've got just 1 times 1 is 1. Then I've got root 2 root 3 is root 6. Minus there, minus root 2's, and plus there, plus root 3's. No more tidying up can be done at all. Number 13, I've got 8 times 8 is 64. The 2 times 2 here gives me a minus 2. And this is interesting. Look, I've got minus 8 root 2's and plus 8 root 2's. So they're cancelling out. And we're just leaving with a 62 at the end there. A good one to note, that one there. It's like that difference of 2 squares before, and the middle bit's cancelling out. And the last one, we've got, so what have we got here? We've got a 3 there, we've got a 5 there, we've got a root 15 there, and another root 15 on the end. So my grand total is going to be 8 plus 2 root 15s. Lots of surds to come. If you want to do any more than that, the next step would be to rationalise a denominator. We will do a brief lesson on that probably in September, but if you can look at rationalising a denominator, you can get a head start in that as well. Just looking back over that, I did spot I made a negative mistake there. Number 10 here, it was a minus here. So the minus, it should have been plus 10 here, and that plus 10 there should have been, that bit there should have been a 19 and not a minus 1. Sorry about that, but as looking back, I checked through my work and noticed little slips. You'll be checking through your work as well, and you should spot little errors and correct them too. So it doesn't matter if you make a mistake. If you go back and check it, put your hands up and go, I did it wrong. Sorry.